Good morning to you, student. Today we are discussing about chapter 7, section 1. The very first topic is related to chemical formula now. A chemical formula will give us information about the number of atoms and the types of elements present in a compound. For example, if we are talking about a compound that is octane, this octane has a chemical formula that is C8H18. So it means that a chemical formula can be represented by using a symbols now. The symbols over here for carbon, we are using C. For hydrogen, we are using H now. So again, in this case, one thing should be very clear to you people, that these in front of C, the subscript is mentioned here, it's 8, while in front of hydrogen, the subscript is mentioned 18 now. So it means that we have 8 atoms of carbon and we have 18 atoms of hydrogen over here now. Now, in this case, when we are talking about now, dear student, in case of this ionic compound, we know that in ionic compound, there's an ionic bond. The ionic bond is formed due to the transfer of electrons between the element. For example, if one element, it loses its electron, the other element will gain the electron. The element that loses its electron, it always carries positive charge. The one that gains the electron, it always carries negative charge. So the positive ion are always termed as cation, while the negative ion are always termed as anion. Now look into this case. This is one of the ionic compound mentioned over here. It is aluminium sulfate. The chemical formula for aluminium sulfate is Al2SO4 taken 3 times. Now dear student, what does it mean now? And how many aluminiums are there, sulfur, oxygen, the total number of atoms of these elements are there. How do we understand it now? Focus here now. Parenthesis around the polyatomic ion sulfate to identify it as a unit. This SO4 is a polyatomic ion. It carries 2 negative charge. So we are going to take SO4 3 times. So in that case, we can say that we have 2 aluminium. This 2 is the subscript of aluminium. So we have 2 aluminium and we have 3 sulfur. This 3 is with the elements present within this parenthesis. And we have almost 12 oxygen. 4 into 3 is equal to 12 oxygen now. So it means that the 3 over here is only with oxygen and sulfur. It is not with aluminium over here now. So if this is one of the ionic compound where we wrote the chemical formula like this one, Al2SO4 whole 3. Now the question arises, can we write the chemical formula for this one as like this one, Al2S3O12? No. We must mention the ions separately. Look, the aluminium always carries positive charge. It is separate from the sulfate SO4 because we know that overall this sulfate carries 2 negative charge. Now, there are many types of ions, the polyatomic ion, monoatomic ion. So what is the difference between monoatomic ions and polyatomic ions? You must understand that the group 1 elements in periodic table, they all contain 1 electrons in their last shell. They can't gain 7 electrons to become stable. Simply, they will lose its 1 electron. When an atom loses its electron, it always carries positive charge. If an element is going to lose 1 electron, it carries 1 positive charge. So group 1 element always loses its 1 electron. They carries 1 positive charge. If I'm talking about group 2 elements, that is beryllium, magnesium, calcium, and so on in the periodic table, you can easily go through that one. Group 2 elements carries 2 electrons in the last shell. They always lose its 2 electron. When it loses its 2 electron, they will carry +2 charge. Group 13 elements, it always carries +3 charge because they are going to lose 3 electrons. While if I'm talking about group 15, they will gain 3 electrons. When an element gains electron, it carries negative charge. So if it gains 3 electrons, the charge will be 3 negative. So look into this one. Nitrogen is a member of group 50. It's a member of group 15. So it means that the nitrogen contains 5 electrons in the last shell. It needs 3 more electrons to become stable now. So it will gain 3 electrons. When it will gain 3 electrons, the charge on a single nitrogen will be -3. Same like that, if I'm talking about group 16 elements, they contain 6 electrons in the last shell, they will gain 2 electrons, so -2. Group 17 elements contains -1, while group 18 elements contains no charge, they're 0 because they're stable, they're neutral. Now, this, if I'm talking about the naming of monoatomic ions, for example, I told you all the metals, group 1, group 2, group 13 elements, most of the these are metals, they lose its one electron, 2 electron, or 3 electron, that gives us positive charge. So whenever we are talking about the monoatomic cation, they can be represented like this one. If so, potassium, K is the sign of potassium, the symbol of potassium. It carries 1 electron in its last shell. So when it will lose its 1 electron, it carries 1 positive charge. So the name of this potassium, when it carries positive charge, it will be potassium cation. Or simply, you can also term it as potassium ion. Magnesium is a member of group 2. It carries 2 electrons in the last shell. So when it loses 2 electrons, it carries 2 positive charges. So the name will be the same. The full name you have to write, you have to add cation at the end. You don't have to write magnesium atom when it carries positive charge. You must mention cation or simply ion at the end. Now, if I'm talking about the negative ions, we call it anion, like group 15 elements, group 16 elements, group 17 elements, they carries negative charge. So over here, the name will end with IDE. If it is fluorine, if it carries 1 negative charge, the name will be fluoride ion. If we have nitrogen, when the nitrogen gains 3 electrons, it becomes nitrogen 3 negative. So it will be nitrite. Look, the name will end with IgE. Oxygen is a member of group 16. When it gains 2 electrons, it becomes O2 negative. The name will be oxide ion or oxide anion. The names of some of the elements, the monoatomic ions are mentioned over here. The positive, the cation name will remain same. Only one thing you have to add, that is at the end you have to write lithium cation, sodium cation, potassium cation. While in case of negative ions, the anion, the name will end with IDE. Look, fluoride ion, chloride ion, bromide ion, iodide, sulfide, phosphide, nitrite, and so on. These are some of the common monoatomic ions of the main groups. Group 1, Group 2, Group 13, 14, 15, 16, 17, and 18. While the transition elements now, that is in between Group 2 and Group 13, the in between these, the periodic table is termed as transition block elements. Now the transition block or D block elements are also known as transition elements. It contains metal, and all the metal I told you, they always lose its electron. So it carries positive charge only. Now the thing is that if you look into this one, we have iron over here. Look into this one, iron 2 and iron 3 over here. It means that the transition metals have variable oxidation state. We call it the same iron exists as +2 as well as +3. While in case of group 1, group 2, group 13, 14, 15, 16, 17, it is fixed. If sodium is +1, it will remain +1. It will be never +2. While in case of iron, we have +2, +3. If I'm talking about vanadium over here, the vanadium is +3 here, over here it's +4. So its oxidation state is changed now. The charges on the transition metals is changed now from sometime +2, sometime +3. If I'm talking here about vanadium, it's +3, over here it's +4, so it's changing now. Now, dear student, how do we understand that? What is the charge on iron now? It is based on the name over here now. Whenever you will see that the name of the element is followed by a parenthesis, and within the parenthesis, if you will see these Roman letters, this will give us information that the iron carries +2 charge. If it is within the parenthesis, if it's mentioned 3, understand that this iron carries now +3 charge, same like for other elements mentioned over here now. Now, what is a binary compound? The next topic is about binary compound. Binary compounds are composed of two elements, and these two elements, for example, in case of ionic compound, when they combine together, as I told you, in ionic compound, one should be cation, the other should be anion. When they combine together, at the end, the molecule should be neutral. We call it binary compound now. So if this is the example for magnesium bromide now, magnesium bromide. Magnesium is a member of group 2. So it means that this magnesium, it is, if I'm going to just write it over here now in the whiteboard, let me share with you. If I'm talking about magnesium, magnesium is a member of group 2, so it carries 2 positive charge now, 2 positive. Wait, okay, it carries 2 positive charge. Now, dear student, if I'm talking about bromide, so bromide is a member of group 17. I told you the group 17 elements always carries 1 negative charge now. A binary compound is a compound. Binary ionic compounds, in binary ionic compounds, the 2 elements combine together, and overall, the compound should be neutral. So, dear student, look. 1 bromide carries 1 negative, 1 magnesium carries 2 positive. So it means they are not going to, the positive and negative charges are not balanced here now, over here now. So we will take 2 bromide over here now. If we are going to take 2 bromide, wait. If I'm going to take here 2 bromide, 1 bromide carries 1 negative, 2 bromide carries 2 negative now. So they will cancel the effect of each other. So at the end, we will get a compound, and this compound is now, the chemical formula for this ionic compound will be Mg, 1 magnesium, and 2 bromide now. So Br2. Now, this one is known as binary ionic compound because over here, the 2 positive and the 2 negative charge are now going to balance each other, and we call it a binary ionic compound. Now, if again, if I'm going to discuss about this one, a general rule to use when determining the formula for binary ionic compound. Now, there are different techniques in order to find out the chemical formula for different ionic compound. The very first one is this one. You have to understand about the charges on these elements. Now, aluminium is a member of group 30. I told you that the group 13 element always carries +3 charge. Oxygen is a member of group 16. I told you that all the elements in group 16 carries +2 charge. So when you know about the charges on this element, you can easily find out the chemical formula for this binary ionic compound. How? You'll just simply do the simple technique that is crossing over. What is crossing over? You will bring the charge over here to the subscript of aluminium over here, and the 3, that is the charge of aluminium, you have to bring it to the subscript of oxygen over here now. Now, if you will see, they are almost equal to each other. Look, 2 into +3 and +3 into 2 negative. So 6 plus 6 minus 6 is equal to 0 now. So the chemical formula will be Al2O3. So you will get this sort of chemical formula. Dear student, this is the last point. You have to go through this one. This is also in your textbook. Find out the the chemical formula for iron 3 oxide. Again, the same thing that if we know the charge on iron, if it is 3+, as we know that oxygen is a member of group 16, 2 negative. So you just have to bring 2 over here, 3 over here. You will get the chemical formula, that is Fe2O3. Thank you very much, dear student. I will see you in the next class.